All right, this is similar to a problem on your stoichiometry homework that you have due very soon. Somebody asked me about it. This is number 8 on your stoichiometry homework. Again, this is similar. This is not the same problem. You have to show your problem worked out. The question is, I've got 0.1 grams of magnesium nitrate. Calculate the mass in grams of each element. All right, again, very similar, but this is a different compound. The technique is going to be the same, but you do your compound. First thing you have to do is use your nomenclature to figure out what the formula is for your compound. Magnesium is a +2. The nitrate ion is NO3 with a -1. And so the magnesium nitrate formula would be MgNO3 parentheses 2. You got to have that. Hopefully it's coming quicker than it has in the past. Each element then means I'm going to have an answer for magnesium, an answer for nitrogen, and an answer for oxygen. All right. So I'm looking for the grams of each of those in a 0.1 gram sample of magnesium nitrate. The first thing that I like to do when I work these problems is remind myself what my equivalences are for dimensional analysis. And 1 mole of X is equal to the number of grams of X using that molar mass from the periodic table. This is going to be needed anytime grams are involved. And in this case, we do have grams involved, the grams of the magnesium nitrate, and we're trying to get that to magnesium, nitrogen, and oxygen. The trick here is that my X has to be the same to do this in one step. And I don't have the same X. I know the grams of my X in this case is magnesium nitrate, but I'm trying to convert that to magnesium. I'm trying to convert that to nitrogen. I'm trying to convert that to oxygen. And so the key, of course, is going to be to go through the mole, your mole mountain. You got to go through the moles to get from one thing to another. And so the first thing I'm going to do is, let's solve for magnesium first. So I'm going to get how many grams of magnesium, starting with the 0.100 grams of MgNO3, 2. I will multiply, you got to show this kind of work, by the ratio that has grams of MgNO3, 2 on the bottom. That has to be in the denominator to cancel. And I'm going to use this conversion factor to get it to moles of MgNO3, 2. And 1 mole is equal to the molar mass in grams. Let me pull up my calculator. A couple people have noticed that there is a typo on the periodic table that you have in your FAQ section. Nitrogen's molar mass is listed wrong. It should be 14.01, not 14.1. Professor Molish is aware, and she will be working on getting that fixed. All right. So I am finding the molar mass of magnesium nitrate. That's a magnesium, 2 nitrogens, and 6 oxygens. Everybody see the 6 oxygens in that formula? All right, magnesium is 24.30. Nitrogen is 14.01, and I'll have 2 of those. And that's your typo, 14.01 for nitrogen. Oxygen is 16.00, and there are 6 of them. So let me add all of that together, 24.3 plus 2 times 14.01 plus 6 times 16, and that is 148.32, and that is a grams per mole. That's the molar mass of magnesium nitrate. And so that's the number that goes here with grams for every 1 mole of magnesium nitrate. I'm going to pull this down to the bottom to get it out of our way. All right. So now I can cancel my grams, and I'm left with moles of magnesium nitrate. But notice I'm trying to get to grams of just magnesium. So I'm going to need to convert from moles of magnesium nitrate to moles of magnesium. I have to go through moles to get this answer. What is that conversion? That's the stoichiometry of that formula. In the formula for magnesium nitrate, there is 1 magnesium for 1 formula. The subscript on magnesium is just a 1, although we don't have to write it. And so that is a 1-to-1. Cancel your moles of magnesium. I need one more step that has moles of magnesium on the bottom to cancel. Now I can go to grams of magnesium because remember, we can get between grams and moles of X, as long as X is the same thing, by using that molar mass from the periodic table. This is, look it up on the periodic table, 1 mole of magnesium is equal to 24.30 grams. And that will be my answer in grams of magnesium. Let's plug that in and get an answer. And I've got 0.1 divided by, hi Dolly, 148.31 times 1 divided by 1, but I'm not going to plug that in because it's the same, times 24.3. You see what I did there? I abbreviated my calculation. I did not click any of the times ones or divided by ones, because anything times 1 is itself, anything divided by 1 is itself. And this answer is 0.016384. It looks like I'm going to need to go to 3 sig figs for my rounding, 0.0164 grams of magnesium. So that's my grams of magnesium. I also need to calculate grams of nitrogen and grams of oxygen. Let's do nitrogen. How many grams of nitrogen are equal to 0.100 grams of MgNO3 times, and my ratio, I'm going to start exactly the same way I did above. I need to cancel grams of magnesium nitrate, so that's got to be in the bottom. The only place I can go is moles of magnesium nitrate, because if I'm going between grams and moles, I have to be talking about the same X. That's the molar mass. I looked it up above. I calculated it above. Oops, so I'm just going to use that value. And my grams of magnesium nitrate will cancel. My next step must have moles of magnesium nitrate on bottom to cancel. I'm trying to get to grams of nitrogen, so the path means I have to go through moles of nitrogen. Now in this case, what I'm doing is I'm looking at that formula and I'm saying how many nitrogens are in that formula. And for every 1 formula, there are 2 nitrogens. That parentheses around the NO3 means that there are 2 NO3s. We also used that fact when we calculated the molar mass. And so that's going to get me to moles of nitrogen, but I'll still have one more step. Moles of nitrogen on bottom, grams of nitrogen on top. That's just the molar mass from the periodic table. 1 mole of nitrogen is 14.01 grams. Remember, there's a typo on that periodic table. Calculate it now. Bring my calculator back. Oops. All right. And I have 0.1 times 1, but I don't have to plug it in, divided by 148.31 times 2 moles of nitrogen times 14.01 equals. That gives me 0.018892 ... grams of nitrogen. If I round that to 3 significant figures, 0.0189 grams of nitrogen. We could go through the same process to figure grams of oxygen. That's the 3rd element. I'm going to do this really quickly so this video doesn't get too long. You're going to start exactly the same way. You're going to have to start with grams of magnesium nitrate, change it to moles of magnesium nitrate, but right here, you're going to convert it to moles of oxygen, not moles of nitrogen. And the ratio there is that you have 6 moles of oxygen in every 1 formula, because in this parentheses, There are 2 NO3 units. That means 6 oxygens altogether. We used that fact when we got the molar mass. And then you'll use the molar mass of oxygen there. I hope this helps.